In this video tutorial, we're going to review the content we covered in class, specifically arithmetic and geometric sequences. So let's start on this sample test with question number 1. It says, which sequence below is neither arithmetic or geometric? Describe the pattern that is neither arithmetic or geometric. What does that mean? Well, we need to assess whether each of these sequences are arithmetic, geometric, or neither. Let's start with the first. And when we're looking at sequence A, I see that it's -4 is the first term. It rises to -1, 2 to 5. I can eyeball that and know right off the bat that this is arithmetic because I can see that it's simply +3 to get from one term to the next term to the next. But if I didn't know that, if I was unclear, or maybe if these terms were further far apart, what we could do is take a term, for example 5, and what we could do is subtract it by the previous term. In this case, it would be 2, right? So 5 minus 2 is going to give us 3. And 3 is the difference. If we were going to do another one, if we were going to do, for example, -1 minus -4, that would also give us +3. Again, that is our difference. So if this is our difference and we're adding by a constant difference to get from one term to the next, then clearly this is arithmetic. Let's take a look at this next sequence to see if it's geometric or neither, or maybe arithmetic again. Let's take a look. The first term is 32, then it falls to 16, and it's getting increasingly smaller, 8, 4. What do we think it is? Well, clearly it's not arithmetic, right? It's not addition or subtraction by a common term, because to go from 32 to 16 is 16, and then 16 to 8 is 8. If we didn't know how to find the ratio, which is the number we're going to be using to get to one term to the next, what we can do is take one term, for example 16, and divide it by the previous term, which is 32. So 16 divided by 32 is going to give us 1/2, and 1/2 is our ratio. And to verify if this is correct, if this ratio is accurate, what we can do is we can apply this ratio to the next term. So 16 times 1/2 is going to give us 8. 8 times 1/2 is going to give us 4. So that the next term, of course, would be 2. All right. So here we have a ratio, a term that's a ratio, the number that's giving us from one term to the next. So clearly this is geometric multiplication, in this case by a fraction. So let's take a look at this last one. I see that it's 5 is the first term, then it jumps to 20, then 45, and then 80. Well, to go to 5, if we go from 5 to 20, we're going to be adding 15, right? And then to go from 20 to 45, we're going to be adding 25. And then to go from 45 to 80 is the addition of another 35. So there's a pattern here, and the next would probably be adding 45. But that's not a common difference, and that's not a common ratio, meaning that this is neither. This is, despite the pattern, this is neither arithmetic nor geometric. All right, so let's move on to number 2. So I see it says James borrowed 500 G's from the bank and is making 2,500 monthly payments to pay it back. All right, so he started with 500,000. He's borrowing a lot. Maybe he's buying a house, and he's making monthly payments of 2,500. We need to write a recursive and explicit equation. So I'm going to underline that so I don't forget. A recursive and explicit equation describing this loan balance, and the first month clearly is 500,000. So that's going to be a sub 1. So we need to write a recursive and arithmetic. Let's get cracking. I can see. So the first thing I'm going to do is write the explicit sequence, and I'm going to write a sub n equals a sub 1 plus the difference times n minus 1, right? And so let's think about this. In this case, it's going to be a sub n. The first term, of course, is 500,000, so I'm going to write 500,000. And what's the difference? Well, if this is going to be increasingly getting smaller, we're going to be subtracting from the balance because he's making $2,500 monthly payments, we're going to subtract 2,500, which is the difference, times n minus 1. So that's going to be this is the explicit equation. Great. Let's take a look at the recursive. What I know is that we need to set it up like this. It's going to be a sub n equals a sub n minus 1. It's the previous term, right? Plus the difference, which in this case is going to be minus 2,500. And then we need to write the first term, which is a sub 1 is going to be 500,000. And this is our recursive sequence, our recursive equation. Let's take a look at question number 3. It says, the population of a particular type of frog in this region is decreasing dramatically. There are reportedly 500 frogs this year. Researchers estimate that every year the population of these frogs can reach 92% of the previous year. So it's declining. This is an endangered species. Find the number of frogs that can be found each year in this region for 5 years. Write a recursive and explicit equation describing this. So let's start with the explicit. It's going to be, and I'm going to write it right here, it's going to be a sub n, and we know it's going to be the first term, in this case 500, times the ratio. What is the ratio? Well, I'm looking at it and I can see that it says 92%. We're going to convert that to a decimal by shifting over the decimal place from this percentage sign 2 spots. So it's going to be 0.92, close parentheses, n minus 1. And this is our explicit equation. So we could simply plug in a number where the n is. If we wanted to find out how many frogs are left 10 years from now, we could simply pop in 10. Right here, this would be 10 minus 1. You can use your handy-dandy calculator to determine how many frogs. But what we need to know is find the number of frogs that can be found each year in this region for 5 years. So let's try a recursive equation to determine the number of frogs over the next 5 years. All right, so here is our recursive equation. It is, of course, a sub n equals a sub n minus 1 times the ratio, in this case, 0.92. And the first term, which is a of 1 or a sub 1, is equal to 500. And when we take a look at application of this equation, we can see that the second year, a sub 2, is the first year, which is 500, right, times the ratio equals 460. So at the second year, there was 460 frogs. At the third year, it's previous year multiplied by the ratio, giving us 423. Fourth year, it's 423.2 times the ratio, which stays the same, giving us 389.3 frogs. And then we're going to wrap it up at the fifth year. This is what the question wants us to tell us. It's the fourth year multiplied by the ratio, giving us 358 frogs. So by the fifth year, this is how many frogs remained. Let's take a look at question number 4. It says, a chess tournament started off with 256 players in round 1. So this is going to be our first term. At the beginning of round 2, there are 128 players. At the start of each round, half of the contestants remain. So that little clue right there indicates that we're going to be multiplying by 1/2 or dividing by 2, but that this is a geometric equation or geometric sequence. And it wants us to write a recursive equation, all right, recursive, describing this sort of behavior in the sequence. How many rounds will it take to get to the winner? How many rounds will it take? Well, the first thing that we need to do is write a recursive equation. So we know that this is the sort of template for it. We're going to do a sub n equals a sub n minus 1. Right? The previous term multiplied by the ratio. In this case, it's 0.5 because we read after each round, half of the contestants remain. A sub 1, of course, is 256 because there are 256 players in round 1. And how many rounds are going to take to get to the winner? Let's find out. I did the math a minute ago. I know that the second round is what? It's going to be the first round multiplied by 0.5 or 1/2, and that's going to give us 128. And so at each round, at each subsequent round, the third round is going to be the second round divided by 2 or multiplied by 0.5, giving us 64. And as this tournament progresses, it's going to fall from 64 to 32 to 16, 8, 4, until we work our way down to the championship match with, at the 9th round, there's going to be only one person remaining. All right, ladies and gentlemen, that is the answer. Let's take a look at question number 5. It says, write an explicit equation that describes the sequence. So the sequence is -2, and then a 5, and then 12, then a 19, and then 26. We need to determine, is this geometric or is this arithmetic? Are we multiplying by a number, or are we adding or subtracting to get to a number? And I can see that to go from -2 to 5, we're going to be adding 7. 5 to 12, adding 7, adding 7, adding 7. And so that's going to be our common difference. But if we didn't know how to figure out the common difference, what we could do is we could take a term, for example, 12, multiply it by the previous term, 5, and that's going to give us 7, which is our common difference, right? If we wanted to use two other terms, let's say 26 minus 19. 26 minus 19 is going to give us 7. So that is our difference, and that's critical when we're writing our explicit equation. So we've determined that it's arithmetic, right? We're adding 7 to get from one term to the next. What else do we need? If we have the difference, I feel like there's something else. Oh yeah, that's right. We need the first term. In this case, it's going to be -2. It's the first term in the sequence. Great. So let's write out this explicit equation, which we know is going to be a sub n equals the first term, which is -2, plus the difference, which is 7, multiplied by n minus 1. Great. Let's take a look at question number 6. It says, write the explicit equation that describes this sequence. All right, so we've got another sequence. Is this arithmetic or is this geometric? So I see it's -64, and then it jumps to +16, and then -4, and then 1. So clearly this is not arithmetic. It's not addition or subtraction of a single number to get from -64 to 16, or 16 to -4. We're going to be multiplying. But what exactly are we multiplying by? Well, what we're going to do is to determine the ratio, we're going to multiply one term by the previous, divide one term by the previous term. So let's say we'll do 16 divided by -64. And when we simplify that, that's going to give us -1/4. So -1/4 is our ratio. Beautiful. So if we wanted to verify that, we could take -1/4 and multiply it by 16, and that's going to give us -4. -4 multiplied by -1/4 is going to give us +1. Beautiful. All right, so again, we need to write this explicit equation. And how do we do that? Well, we're going to be doing a sub n equals what? The first thing that we need is the first term, and the first term in the sequence, of course, is -64. All right, so a sub n equals -64 multiplied by the ratio, right, which we determined is -1/4 raised to the n minus 1. So then we could plug in a number for our term, either right there and right there, and that's going to give us the term later on in that sequence. Question number 7 says, this is pattern below geometric, arithmetic, or neither, and why? So when we take a closer inspection, I can see that after this first shape, there is a single triangle. When we're looking at this second one, we've got how many? 4. And when we're looking at this third and final shape, how many do we see? So it's 4 plus 5, 6, 7, 8, 9. All right, 9. Is there a common difference to get from 1 to 4 to 9? So if we did 4 minus 1, it's going to give us 3. 9 minus 4 is not 3. It's 5, of course. So while there may be a pattern, there's not a common difference. So we can rule out, let's rule out arithmetic. All right. What about geometric? Is there a number that we can multiply? So 4 divided by 1, or 9 divided by 4, that's not going to give us a common ratio. So that we can eliminate geometric as well. So the answer is neither, because what? There's no common difference. or common ratio. Let's take a look at number 8. This is a little bit of a throwback. Find the missing terms in the arithmetic sequence. So we've got 55 as our first term, right? Something, 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 7. How do we figure that out? Well, what we're going to do is we're going to take the last term, which of course is 7, minus 55, and then we're going to divide that by what? We're going to divide that by the number of spaces between each term. So, or what I like to do is count out these commas. So 1, 2, 3, 4. Let's divide this by 4. And when we do that, 7 minus 55, and then divide that by 4, that's going to give us negative 12. So then what we can do, so negative 12, of course, is the difference. Great. Now what we need to do is use this number, negative 12, the difference, to determine what the missing terms are. So if we zoom in a little bit, 55 minus 12 is going to give us 43. And then, of course, if we subtract another 12 again, 43 minus 12 is going to give us 31. Beautiful. And then we're going to subtract a negative 12 again, and that's going to give us 19. 19 minus 12 is 7. Sure is. Tremendous. So this is our answer, 43, 31, 19. When we take a look at number 9, it's clearly a recursive equation, and we can see that the first term is 4, and we can see that the difference is positive 6. So we're going to be adding 6 to each term, and it wants us to list out the first 5 terms. So we know that the first term is f sub 1 equals 4. What is the second term? Well, what we can do very simply is add 6 to the first term, which is 4, and 4 plus 6 is going to give us 10. So the second term is equivalent to 10. The third term is the second term plus the difference, giving us 16. The fourth term is the third term, right, n minus 1, plus 6, the difference, giving us 22. And then the fifth term is 22 plus 6, giving us 28. When we analyze number 10, we can see that, again, this is clearly a recursive equation. We've got our first term, which is negative 3, and we've got our common ratio, which is negative 2. We're going to be multiplying each term by negative 2, and it wants us to list out the first 5 terms. So we know that the first term is negative 3, right, because it says it right there. What's the second term? Well, the second term is going to be the first term multiplied by negative 2. Negative 3 times negative 2 is going to give us positive 6. The third term is going to be positive 6, right? The previous term multiplied by negative 2, giving us negative 12. Fourth term is the previous term multiplied by the ratio, giving us positive 24. And the fifth term is the previous term, positive 24, multiplied by negative 2, giving us negative 48. Number 11 says, will all geometric sequences that grows always eventually outgrow an arithmetic sequence, and how do you know? The answer is yes, they sure will, because geometric sequences grow by a ratio and not by a common difference. When you multiply, you're going to be able to increase more rapidly, at least over time, than an arithmetic sequence. Given 2 terms in the geometric sequence, find the first term. So we know that the fourth term is 12 and the fifth term is 6. How can we figure out what the ratio is to ultimately figure out what that first term is? So what we can do is use our formula to determine the ratio, and we're going to take one term and divide it by the previous term. So I can see that a sub 5 divided by a sub 4 is the same thing as 6 divided by 12. And we can simplify that to 1 over 2, right? So this is going to be our ratio. And what I know is that if we're applying the ratio to something, each subsequent term is going to be getting smaller, so that if a5 is 6, then a sub 6 is going to be what? 3. And a sub 7 is going to be 1.5. But that's not what it's asking us. It wants us to determine what the first term is. So if we can then reverse that. So if we're going to be going backwards, the fifth term is 6, the fourth term is 12, then let's multiply the inverse of 1/2, inverse of the ratio, multiplied by 2, meaning that a sub 3 12 times 3 is, 12 times 2 is going to be 24. All right, we're multiplying by 2. We're doing the inverse of this ratio. So what's a sub 2? It's going to be 48. And finally, what is a sub 1 going to be? This is what we're looking for. This is the first term. 48 times 2 is going to be 96, and 96 is our answer. 96 is the first term.